We have completed oxidation number, nomenclature. Now, today is all about atomic mass, mole, and Avogadro constant. History is counting atoms, but atoms are too small to count directly, right? So scientists have created some smart counting system, and that system is based on atomic mass, mole, and then Avogadro constant. It's like counting the atoms. Since we can't count them directly, these are the smart counting system invented by scientists. We're going to learn about atomic mass unit. Atomic mass unit, the symbol is U. Atomic mass unit in the sense, one U is equals to 1/12 of the mass of 112 carbon atom. Like only 112 carbon atom, right? The definition of atomic mass unit is it is equals to 1/12 the mass of the 12 carbon atom, right? Scientists have given value for it. This is the value for 1U. 1U is equals to 1.66 into 10 to the power minus 24 gram. Now you might wonder why 12 carbon or carbon 12 or whatever it is, because it is used as the standard reference. Just like 1 meter is defined using a standard, right? Carbon 12 is chosen because it is stable and easy to measure, and then they are always available in nature. Atomic mass unit is just a comparison unit, okay? It's like this. Now the carbon 12, if we imagine like carbon 12 is 12 kilogram, right? Imagine carbon 12 is 12 kilogram, then 1U, I mean the one atomic mass, is equals to 12 kilogram. That's what simply meant here. So when you say oxygen, right, it is equals to 16U. Likewise, sodium, it is equals to 23U, which means oxygen here, okay, is 16 times heavier than 1U. This is how simply we compare. That's all about atomic mass unit. Moving on to average atomic mass. It's a very important concept. Average atomic mass. A very important concept. Many students think atomic mass is a whole number, but atoms exist as isotopes because nature is messy, right? For example, if I take chlorine, okay, we have chlorine 35 and chlorine 37. This one exists 75% in the nature, and this one exists 25% in the nature. We calculate weighted average. So that weighted average is only average atomic mass. Average atomic mass, which is equals to sigma percentage abundance into isotope mass over 100. Now, most of the students, right, they are confused when it comes to average atomic mass. Now, for example, if I take a classroom, okay, in the classroom, okay, now there are 75 students, right, who are scoring 35 marks, and there are 25 students who scores 37 marks in a particular subject. Now, if we ask for the average, class average, okay, we use the same formula like this, right? So it is not complicated. right? It's just the weight average, right? The weight of them, right? The weighted or the weight average. That's all about average atomic mass. Next we have mole concept. Third one. Mole, right? Remember, it is just a counting unit. Mole is just a counting unit. Like for example, if I take 1 dozen is equals to 12 items. Nah? Likewise, 1 mole is equals to 6.022 into 10 to the power 23 particles. That's all. This number is called as Avogadro constant. Okay, which number? This number. This number is called as Avogadro constant. It is not a random number. It connects atomic mass and grams. Like if atomic mass of carbon, right? Atomic mass of carbon is equals to 12U means, right? The molar mass of carbon is equals to 12 grams per mole, right? The 12 gram of carbon exactly contains 6.022 into 10 to the power 20 atoms. The triangle trick. I call it triangle trick. When I was doing A levels, I studied this way. Okay, so this is how it is: mole, mass, and then particles. See, they are in a triangle. Okay, so this is my triangle trick. Now, mass to mole. Okay, from mass to mole, this is the formula, right? N is equals to mass over molar mass. From moles to particles, N is equals to N into 6.022 into 10 to the power 23. When I combine this and this, I get N is equals to mass over molar mass into 6.022 into 10 to the power 23. Okay, this is a triangle trick that I used during my levels. Here, this is number of particles. This is number of moles. This is the entire trick under this. And one more thing that I missed to say is molar mass. Okay, this one, molar mass. If I take molar mass, right, molar mass, this is the symbol, grams per mole, is equals to mass in grams over moles. But practically, molar mass is equals to numerical atomic mass in grams. For example, if I take oxygen, oxygen is 16U. Therefore, the molar mass of oxygen is 16 grams per mole. Molar mass is equals to numerical atomic mass in grams. Okay, atomic mass we can't measure. It is microscopic, but molar mass can measure. That is microscopic. Let me put a chart for this: atomic mass versus the molar mass. Right? This is the molar mass and this is the atomic mass. Okay. Atomic mass, the unit is U, but here the unit is grams per mole. Here we measure the mass of one atom, but here we measure the mass of one mole. and this is not measurable, but this is measurable. These are the differences between atomic mass and molar mass. In some cases this one can be useful, the triangle trick. So keep it in mind. You don't have to memorize anything, just keep it in mind. You're wondering why I multiplied here with 6.022 into 10 to the power 23. Because mole means that many particles, right? So that is simple, there's no magic or anything. And why I divide by molar mass is because molar mass tells how many grams are there in 1 mole. So if I divide grams by the grams per mole, okay, I get how many moles. The units will get cancelled. Here there's a gram now, this and this one will get cancelled, so I'll get mole. Once again, atomic mass compares atom using the 12 carbon standard reference, and the molar mass is the atomic mass expressed in grams per mole. Here it is, and the atomic mass is also the atomic mass, but we express in grams per mole. The 1 mole contains 6.022 into 1 mole contains 6.022 into 10 to the power 23 particles. And to convert mass to particles, we divide by molar mass and multiply by Avogadro constant. So that's all for today's concept. See you in the next video, that is composition of mixer. Remember, mole is just a unit, right? Measuring unit. Try to go through these notes and stuff. As I mentioned, if you'll need these notes, DM me. Even if you comment, I could share them. And then stay tuned. If you haven't subscribed, subscribe, and see you in the next session.